Okay, so good morning everyone. I welcome you back to my YouTube channel presenting this wonderful tutorial is the Mental Humble Clement. And of course, this is Etsy Learning Academy. And if you haven't yet registered for personal lessons, ensure that you inbox me on my WhatsApp number on this particular line, which I'm going to present on the screen, which is a +260 777 46. If you're finding challenges either in mathematics, physics, chemistry, biology, or whichever course, just ensure that you inbox me on that same WhatsApp number and I'll be able to register you at Etsy Learning Online Academy, where we are able to learn almost every day from Monday to Sunday. Okay. Now, we have quite very interesting questions on trigonometry, and particularly these are trig identities. And we are going to solve the majority of them, and I'll give you work, I think 2 questions, and then we also do some questions on half angle identities. Now, believe me, this is very, very simple. In my first lesson, I think at HC Learning Academy, I was able to give you several trigonometric identities which you don't have to master, but you can actually be able to derive them from just about 4 or 3 trig identities. Now, we start. They're saying simplify the given trigonometric expressions to a single trigonometric function or a constant, right? Then the first question is simply A. They're saying this is going to be sine x minus sine x tan x. How do we simplify this? Now, I want you to notice something. In this particular trigonometric expression, there is only one part which we are able to change so that we may make everything simple. Which part is that? It's the tan x, because we know that tan x is a common trig identity of sine x over cosine x. So this can also be written as sine x minus sine x, open bracket, then sine x over the cosine x, right? Now notice, from here, we are able to expand everything, and if we expand, we are going to have sine x minus, what is sine x multiplied by sine x? This is going to be sine power 2 x over the cosine x. All right, so you can even include the 1 there for balancing, and then you can find the common denominator, which is going to be just a cosine x. What is cosine? What is 1 into cosine x? 1 into cosine x is cosine x. Then cosine x multiplied by sine x is going to be sine x cosine x. Then minus, what is cosine x into cosine x? It is 1. 1 multiplied by sine to the power 2x is just the same, right? Which is sine 2x. Right. When we reach here, what can we do about it? Very simple. You discover that we've got sine x cosine x minus sine squared x. So we can just factorize. Well, what is common is simply sine x. Then what is going to remain is cosine x minus, and then we're going to have sine x there. So if we multiply this, you will discover that we will actually get the same thing, right, over cosine x. Now, when you reach here, you would want to be smart. So you would want to simplify everything to the least it would be simplified. So this can also be written as sine x over cosine x, then open bracket, this is going to be cosine x minus sine x. Then you discover that sine x over cosine x is simply tan x. Then you open the bracket, and that gives you cosine x minus sine x, right? This is how simple this particular question is. Now we go to the second one, which happens to be our b. B, they are saying it's cosine squared x minus 1, then tan squared x plus 1, right? So we have cosine squared x minus 1, then tan squared x plus 1. Now the key to trigonometric identities is simply to be able to figure out what is easy and to be able to remember your trig identities. Okay? To be able to remember your trigonometric identities. So the two are trig identities. How do I know? Because I know, please make sure that you go through my previous video, or you get the video from HC Learning Academy. You'll be able to see how I was able to present all the trig identities. So look at this. Tan squared x plus 1 is a common trig identity known as secant squared x, right? There is also another trigonometric identity is very common, sine squared x plus cosine squared x is actually equal to 1, right? So now look at this. I'm able to actually manipulate this. If I'm to make sine the subject, okay, then this is going to be cosine squared x, right? Then this one will go on the other side. It becomes minus, okay, minus 1, then equal to. If I'm able to get 1 and take it on the left-hand side, that implies I can actually get this sine to the power 2 and take it on the other side. Then it becomes minus sine squared x. Okay? Then that implies that whatever is inside here is minus sine power x. Very simple trigonometric identity there. Then whatever is going to be inside is secant squared x. Very good. Okay? That is how you're able to make whatever is inside. Very simple. Right. Now, upon reaching there, okay, upon reaching there, you are able to multiply whatsoever is there. So, either way, you can say minus sine squared x, then this side, this is going to be 1 over, so secant, okay, secant is just 1 over cosine squared x, okay, like that. If you multiply, this is going to be something like sine power 2x over cosine power 2x, right? What is this trigonometric identity? Remember, sine x over cosine x is just tan x. So even this part, because this is a negative, so we're going to factor out the negative, and then we're going to remain with sine power 2x over cosine power 2x, right? What is this? It is tan. So this is going to equal to minus tan squared x. Okay? That is how you find this particular question there. Right? It's very simple. I'm just using the normal trigonometric identities that we all know. Okay? So the key is simply, the key under trigonometric identities is simply to do the right thing. Even if you don't know where the question is going, keep doing the right thing, then you discover that at some point your eyes will be able to open and you see where you should be able to actually end. Let's lab the board so that we actually solve more questions. Okay, so we're going to do a C. Let's see what it's saying. C is cosine z plus sine z tan z. Right. Okay, so this one is cosine z. Okay, we've been given cosine z. Then they're saying plus sine z plus sine z, then tan z. Right? Now, look at this. Which part are we able to change or manipulate so that we're able to make everything simple? Right, you got it correct. It's the tan z part. So this is going to be cosine z plus sine z, you open the bracket, tan is simply sine z over cosine z, like that. Okay? Then from there you can do your multiplication. This is going to be cosine z plus sine z. Okay? Sine z multiplied by sine z is sine z power 2, right? Sine z power 2 sine z power 2 over your cosine z. You can put your 1 here. Then you can find the common denominator. Okay? You can find your common denominator, which is simply happens to be cosine z. 1 into cosine z, it's cosine z multiplied by cosine z, it's going to be cosine squared z, plus, what is cosine z into cosine z is 1, then this is going to be like sine squared z. Now look at this, it's given you a very beautiful trigonometric identity there, which happens to be our cosine squared x plus sine squared x, which equal to 1. So whatever is going to be on top is going to be 1, then cosine z. Then what are we going to have? 1 over cosine z is simply, okay, very good. Okay, this is just secant z. Okay, this is how you get this particular question. Is actually very, very simple. Okay, it's actually very, very simple. Now, let's get to find another one. We can do D. What is D saying? Okay, let's go to D. D is secant y minus cosine y over tan y. Okay, so you have your secant y minus cosine y over tan y. Now, remember, I said the key to trig identities is simply to do the right thing and not to know where the question is going. You don't have to know where the question is going. What you have to do is the right thing, right? So the first thing that I'm going to do, I'm going to dodge this tan y. I'm going to forget about it. Then I'm going to work with whatever is on top. So I know that secant y is actually 1 over cosine y, then minus cosine y. So that is a very good example of doing the right thing, but not really knowing where the equation is going. Then from there, I can actually find the common denominator, which is going to be cosine y. Then cosine y into cosine y, it is 1 multiplied by 1 on top, it's 1 minus 1 into cosine y, it's cosine y multiplied by cosine y, it's going to be cosine squared y, right? Now, upon reaching at this part, I can now bring in all over by tan y. But I know that tan y is simply sine y over cosine y, right? And because tan is in the division part, if I'm to introduce a multiplication part, then I expect that this is going to be go on top like that, and the sign will come down like that. So I'm going to have something like 1 minus cosine squared y over, then this is going to be cosine y, okay? And then this is going to be cosine y over sine y. Well, what next do we do from there? Very good. It's actually very, very simple, guys. Look at this particular part. Look at this particular expression. Remember that sine squared x plus cosine squared x is actually equal to 1, right? And that implies that sine power 2x is equal to 1 minus cosine squared x. This part is what we have here, and that's the expression we have. What does that tell you? It tells you that this part is actually sine squared y over by cosine y, right? Then this side we're going to have cosine y over sine y, like that. Now look at this, guys. You can cancel out the cosine y. Everything now becomes simple. I don't know where the equation is going, but I just keep doing on the right thing. I'm inserting in right equations, right trigonometric identities, and that's the whole thing that is important. I can cancel out this and cancel out this. Then I'm going to remain with a sine y here, and that becomes my answer. Okay? That becomes my answer. So this is basically how you answer trig identities. Let's check what we have. Okay, we solve E. E looks complicated, but it is actually the simplest amongst what we have solved. Now let me show you how E is actually the simplest. Let me wrap the board. Look at this. E is simply tan theta sine theta, okay? Then second squared theta minus 1. So E is actually, so this is going to be tan theta sine theta over, this is going to be second squared theta, then minus 1, right? Minus 1. Now look at this. Just one trig identity, and we solve this question. It looks complicated, but actually my eyes are able to see how simple it is. Let me show you. Remember that tan squared x plus 1, I gave you this trig identity I gave you, and I said this is second squared x, right? And that implies that if I'm able to take this one, this side, then I'm going to remain with tan squared x is equal to second squared x minus 1, right? Right? Right. If that is correct, then that implies that this whole part here is equal to tan squared x. And that opens the door. So if this came in a test or an exam, the moment you establish the trig identity, you begin to smile. Okay? So, now, let me simplify everything. This is just the same as tan theta over tan theta. Then I'll put a dot to signify multiplication. Then all over by tan theta. This is just the same because if I do the multiplication, tan multiplied by sine, I'm going to get tan theta, then sine theta, right? And this is going to be tan squared theta, which is just what we have here, okay? Now, let's finish it. Look at this. This and this can cancel, so you're going to have a 1, and then you're going to have sine theta over tan theta, which is just the same as sine theta over 1 and then multiplying by, remember if we multiply, this is tan, we expect that the cos would be on top and the sine would be down here, and this cancels and that cancels. Beautiful. And we get our final answer, which happens to be a cosine theta. Okay, this is how simple this is. Now, if you understood my concepts and I'm able to solve these questions, I want you to do F, which happens to be simple, one trig identity there, and you solve it, and also this particular question. Okay? So I'm going to give this one, let me just give it 3 marks. Let me also give this one 3 marks. You send to this WhatsApp number, okay? And of course, if you're interested in personal lessons, make sure that you register for personal lessons at Etsy Learning Academy by simply inboxing on this same WhatsApp number, and you'd be able to get registered for personal lessons. You wouldn't be able to fail not even one question. Guys, let's go to something interesting. Well, I've been given a question what they're saying, we solve the following trigonometric equation. Now, I'm going to solve the B, because I'm interested in you solving the A. They are very simple. Now, under trigonometry, actually, there is a part which we call double angle identity and half angle identity. So double angle identity, of course, we learned at HC Learning Academy. Even double angles, half angle, I think I taught most of the things. Make sure that you access, of course, when you get registered, you access all the lessons for the previous lessons so that you start revising and going through, so no one is actually late. Now let's go. Now look at this. Let me do the solution. What's the difference between half angle and double angle? A double angle is going to look like this. We've doubled the angle, and I was able to prove that this angle is actually doubled. A double angle comes about whenever you have sine theta, okay, or let me say sine A equaling to sine B. If sine A is equal to sine B, that implies that in the angle theta it is going to be sine A plus A. Sine A plus A is equal to 2A. Okay, sine theta plus sine theta becomes 2 theta. That's how you get the double angle. Now, half angle is going to look like this. This time around, you're going to have your theta over 2. Okay, this is what we call half angle. Okay, these are half angles. Now, there are particularly 3 of them, but actually, I'm sure by now you know them, so I'll be able to just solve them so that you see how we solve. I'll go with B, okay? So sine theta over 2, and then they're saying plus cosine theta is equal to 1. Now, it's not complicated. It's not complicated. It will never be complicated. Actually, A is actually the simplest. Now, look at this. There is a half angle identity I want you to remember. When you have sine theta over 2, this is just the same as square root of 1 minus cosine theta, right, over 2. So, where there is this part here, you just replace with what you have. So this is just the same as root of 1 minus cosine theta over 2. Then this is going to be plus cosine theta equal to 1. Now, because I'm a mathematician, I want to make everything simple. This is going to be 1 minus cosine theta over 2. You know what you do? You take the cosine on the other side so that it becomes 1 minus cosine theta. It becomes very simple for you to cancel the square root by simply squaring both sides. So this and that will go. Then you're going to have 1 minus cosine theta over 2. And then this is going to equal to, now let's try to expand whatever we have there. So this is going to be 1 minus cosine theta, and then 1 minus cosine theta. So 1 multiplied by 1, it is 1. 1 multiplied by negative cosine theta, it's going to be minus cosine theta. Negative cosine theta multiplied by 1, it's minus cosine theta. Negative cosine theta multiplied by cosine theta, it's positive cosine squared theta. Then this is going to be 1 minus, this is going to be 2 cosine theta, because those are like terms, plus cosine squared theta. Right, that is what we have. So actually, we can actually replace it there so that it becomes cosine 1 minus 2 cosine theta plus cosine squared theta. Okay, very interesting, very interesting. Okay, so don't get lost up to that part. When you reach there, you can actually now cross multiply. So if you cross multiply, then that implies you're going to have 1 minus cosine theta equal to 2, open bracket, 1 minus 2 cosine theta plus cosine squared theta. Then this is going to be 1 minus cosine theta is equal to 2 multiplied by 1, it is 2, minus 2 multiplied by 2, it is 4 cosine theta plus 2 multiplied by cosine to the power 2, it is 2 cosine squared theta. Now when you reach there, look at this, guys, look at this. This is a 1, so if a 1 goes this side, it subtracts with these 2, so we're going to have a positive 1, right? I just want to do everything directly. This is a minus 1. If it goes this side, it will subtract with minus 4 cosine theta. So this is going to be minus 3 cosine theta, right? Right? Then from there, we are going to, by the way, I just got this and took it this side, right? Then this is going to be 2 cosine squared theta, okay, like that. And then this is equal to 0. I can just put everything together like this. Then minus 3 cosine theta plus 1. So beautiful, guys. So beautiful when it reaches at this stage. Why am I saying this is so beautiful? Look at this. Look at this, guys. This is... Sorry. I want you to look at the magic that is happening here. This is ax to the power 2. Okay? Ax to the power 2 minus bx plus c equal to 0. What is that? It's a quadratic equation. It becomes a quadratic equation. And if it becomes a quadratic equation, then bingo, everything should now be simple. Right? So what do you do from there? We can now find the product. The product is simply 2 multiplied by 1, so it is going to be 2. And the sum is simply negative 3. If that is the case, what are the factors? Two numbers, we multiply them, they give us 2. It's going to be minus 2 there. Okay? And then another number is going to be negative 1, because negative 2 multiplied by negative 1 should give us positive 2. Negative 2 plus negative 1 should give us negative 3. So from there, we can do the needful. So we're going to have 2 cosine squared theta. Then this is going to be minus 2 cosine theta minus 1 cosine theta plus 1 is equal to 0. Okay, this we know. Then I can factorize. What is common? 2 is common. What else? Cosine theta is common. Yes. Then what is going to remain is cosine theta minus 1. Even here we factorize. What is common? Negative 1 is common. Then cosine theta minus 1, okay, like that, then equal to 0. Let's check. Everything is set. Now we can wrap this part. Now we can wrap that part. Sorry. So upon reaching here, we are going to have this part, 2 cosine theta minus this part, so it's going to be minus 1 equal to 0, first equation. The second equation is this one, which is inside, which is cosine theta minus 1 equal to 0. Two equations, guys. So now we can say 2 cosine theta is equal to 1 over 2 over 2. So this is going to be cosine theta is equal to half. The other side is going to be cosine theta is equal to 1. Okay, now we can solve. Now, look at this. There is something really important which I want you to know. How do you find cosine theta is equal to 1? Well, just remember this box, which I'm going to draw. So you are in your exam, you just do it roughly, very quick. So you say 1, 2, 3, right? Okay, should be 4. Okay? Should be able to remember this. So this is going to be your sine. So you start with your sine, then your cosine, then your tan. Then this is going to be 30 degrees, 45 degrees, 60 degrees. Now at HC Learning Academy, this diagram should be in your mind. How do you make everything simple? Very simple, guys. Look at this. Just make sure you write over 2, over 2, over 2 everywhere. Then start increasing by 1. So 1, 2, 3. Then in cosine, do the same thing, over 2, over 2, over 2. Then start increasing by 1 from this side. So 1, 2, 3. Then this side, you square root everything. So because this is 1, square root of 1 is 1, then this is going to be a square root, this is going to be a square root. Right? We square root everything anyway. Even this side, you square root, you square root, you square root. Now, you can't square root 1 because square root of 1 is 1. So this side, you leave it like that. This side, you leave it like that. Then, in tan, you do the same thing. So it's going to be 3 over 2. You just copy whatever is on top. Then, you just write your 1 here. Then, you drop the square root of 3. And that's how you're feeling. Now, there we had cosine theta is equal to 1 over 2. So just go where the cosine is. Cosine is here. Then where is cosine 1 over 2? It's here, and the angle is 60. So cosine theta is equal to 1 over 2. The value of x that you are finding is 60 degrees. Now, since cosine is positive, go in the quadrant where cosine is positive. Bingo. It's in the fourth quadrant, and in the fourth quadrant, that's where you have 360 minus theta. So just say 360 minus 60, and then you're going to get 300. So your values of x are going to be x is equal to 60 degrees, then 300 degrees. What else? We have one equation remaining. The equation is here. Now, since cosine is equal to 1, what do you use? You use your unit circle. You use your unit circle. Get the unit circle from HC Learning Academy. It's very simple, guys. You get your unit circle. Under the unit circle, you discover that cosine is equal to 1 because cosine represents an x value. And there's only one part where your x value is equal to 1, and that is at 360 degrees. So, 360 degrees. Okay? That's how you find this particular equation. So you find your values of x is going to be 60 degrees, 300 degrees, and 360 degrees. Okay? You can use the same concept to actually solve this one. So I'll give it 4 marks, and then you'll be able to solve everything. If you found this video interesting and helpful, don't forget to subscribe to my YouTube channel and also hit the like button, and also don't forget to share. Above all, register for personal lessons at HC Academy and enjoy our everyday sessions from Monday to Sunday with the mentor Hampir Kliman. Thank you so much.